So we have just time for a few questions before we go to lunch. And let me just say before I call on Anna that today we have a press release for the phenotyping of this mouse. And we talk about why we made it and what's happening. And so check that out. Check out our press release out today.
So maybe what I'm going to ask, I don't know if this is on, yes, is in the press release. But Matt, from what you explained, what I mean was hearing how will that be available, that model to the community? Is this going to be available as a fee per service like the other models going on at JAX because you have many neurodevelopmental? How can the companies in this room put their drugs on your model tomorrow?
So this model is going to be deposited into the MMRRC, so it is going to be publicly available. So anybody who wants to get their hands on the mice, they can get their hands on the mice. Also, anybody working with the SRF, we're working with them on this, and I have live colonies of these animals. If somebody has a pressing need, we can make sure that we can get them animals pretty quickly. So it'll be there. And again, the ultimate goal is to make this as a resource for the community overall.
Yeah, before you go, I want to point out that the nonsense mouse is amenable to all the precision medicine treatments that we were thinking about. So not just tRNA suppressor, which is it's the only one. It's the only nonsense is the only thing you can really do to test a tRNA suppressor, but the nonsense also works for ASOs, for AAV, lots of things, base editing, all kinds of things. So we've actually already, and it says this in the press release, we've already sent the mouse to Tevard, and so they're doing experiments with it already. And so the people at JAX, and there's actually a lot of divisions at JAX. This is he talked about his division, but they're super nice, and we've been able to get mice even before they're publicly available. The mouse is on the website, and in our press release, we talk about all the different Syngap models. So we highlight, there's lots of links in there, and you can find all the Syngap mice that are at the JAX, including the humanized mouse and the fully humanized mouse, and then the other patient-derived. So please, over here.
Hi, Matt. Greg Robinson from Tevard. So it's great to have, the availability of this mouse. I was interested in your gender differences and wondered if you had any more thoughts on the male to female phenotypes that you see.
Unfortunately, I don't have too much more to add to those, mostly because we did see kind of a back and forth. What I would say, and I'm being cautious about this because when it comes to stuff like 3-chamber social approach or the center dwell time on open field, some people will equate those results as autism-like, or they are anxiety-like. And I know there are some people out there who will basically fight on a hill about how much can you say a mouse has autism? I mean, autism has a lot of social aspects to it, and while mice are kind of social, they don't nearly have the human level of complexity. But what I would say is what we do know is for a lot of autism spectrum disorders, there are very big differences between males and females on how it presents. So that could be a portion of what could explain why we're seeing some differences between the sexes in the mice as well.
I have one comment and one question. This is Mike Boland from the Center for Epilepsy and Neurodevelopmental Disorders at Penn Medicine. We're the ones that developed the humanized SYNGAP1 mouse. We're also knocking in a nonsense mutation into the humanized locus, so that mouse will be available sometime probably Q3 of next year for testing human-specific therapies in a nonsense on a nonsense mutation. And given the discussion about missense mutations and their ambiguity in SYNGAP, do you have plans to make a missense mouse, like one of the more recurrent missense? We now have, what, 4 or 5 haploinsufficient mouse models. And based on what we know from Brandon Brown's work right here, he can pretty much fill in all of the blue boxes that you had on your slide, Matt, for the humanized haploinsufficient mouse. And so now we have a pretty good understanding of the haploinsufficiency in a mouse context, in a mouse genomic context. Is there any plan to make a missense, like a G344S or anything like that?
Currently, no, but I think that is something that definitely needs to happen.
Yeah.
We already have, I think, pretty good resources as far as the nonsense-based approach to a lot of this. But as we've heard earlier today, because Syngap does have multiple isoforms, and we know that those isoforms are differentially expressed in different places, and that patients with mutations in different regions of the gene are displaying symptoms slightly differently, it does speak that there are some nuances to this gene, to this disease. And so just having a nonsense model, which might be a catch-all for most patients, having missense models that kind of complement that, I think, are not only useful for the community itself and making sure that as we are developing new therapeutics, those therapeutics just don't work for one subset of patients. We want things that can help everybody get back to where they want to be. Yeah.
Can I ask one more question? You have this large panel of iPS cell lines. I assume some of those are, or at least a handful of those are missense variants. Has anybody looked for haploinsufficiency or disease mechanism in those lines?
I think a lot of work is coming from COBA and Quadrado. So is Georgia here? Yeah. So can you answer that? Are the missense lines haploinsufficient? I think that's a question for a different panel. Yeah. Somebody over here.
I had a question for Kathryn. The variant viewer was an amazing resource to put together with, really just volunteer work. And I did notice one thing that was pretty interesting for us from a basic science perspective. There were human geneticists, of course, reported the 5' like N-terminus region were had mutations, human mutations that were relatively less severe. But in the variant viewer, it looked like there was a curious absence of disease mutations in the last 2 or 3 exons as well. And I was wondering if that's something that you see with larger, patient community as well.
Yes. Yeah, we do see that. We see less in the exon 18, 19 and less in exons 1, 2, 3, and even 4. So I think this is a case where having some targeted mutations that look at specific isoforms would be really helpful. So sometimes you just want to study patients, but sometimes you want to say, here's my thought. Let's knock these out one at a time and see what happens. So I think it would be interesting to make iPSC lines that way. But yes, most of our mutations are between exons 5 and 17.
Thank you.
Mike?
I just want to respond to Mike Boland's comments a little bit. I love the fact the question came up because it means we've done our job. We have been pounding the table on missense mutations for a while, right? And what I say to families, and I welcome any clinician or researcher here to correct me or improve my description, is that the dogma is broadly that all protein truncating variants act the same, right? So it was assumed that a het worked just fine. But then we realized that some of these precision therapies, we needed to actually have a gene to fix, right? So we put in the humanized locus. And then with the 2 patient-derived mutations you see there, those were funded in Professor Hugenier's lab years ago, and they've just come into circulation. We did the Q503 because Tevard needed a Q stop to prove their technology on to have preclinical work. And the investment there, and I use the word investment very, very carefully, was to give Tevard the data they need to include Syngap in their trials and include Syngapians in their trials, right? Let's be clear, every missense family in this room who's met me has been hit up to sponsor a cell line for their missense because every PTV is assumed to be the same. So it's worth understanding and treating the PTVs. And every missense is assumed to be one of a kind. The dollars matter. We have deployed over $6 million against science in 6 years. That's impressive. But mice are not cheap. Broad numbers rounding up slightly, up to 50 grand to make them, up to 200 grand to characterize them. Those mice are $250,000 each. So the idea that we're going to decide to pop out 10, pick a number, missense mice is if you've got a few $1,000,000 to burn, call me. But otherwise, step one is the iPSCs. And step two, which we've already done, is the in silico work we're doing in Finland. We are committed to missense, but making a missense mouse is a big chunk for us at a time when we're turning to the clinic. What we want to do is really take what we've got, treat some Syngapians, figure out what somebody who was born with SYNGAP1 related disorder looks like when they get better. And we will continue to pound the drum on missense. But the idea that we're going to start making missense mice with the resources we have and the priorities before us is unfortunately going to be a stretch. But I'm really glad we're asking, because it means we've done a good job of putting missense on the map. Because when I started SRF, people were like, oh, we'll get to the missense later. And we have changed that conversation, and we are investing against missense. And I want every missense family to hear that. Yeah.
Whether or not it's haploinsufficient or dominant negative or
Yeah.
protein hypomorph or whatnot.
Yeah, and I want to point out Dr. Michael Courtney's work looking at assays. So he's got 5 assays. He talked last year, and he's not here this year, but I'm sure he'll talk next year about his missense work, finding 5 different assays that have very different functions. Because when we talk about Syngap has a lot of functions, and so a missense can be anywhere along the gene, and so potentially, let's say we have 5 different functions, a missense might affect one or a few more than other functions, right? So I'm not going to go with Mike's answer and say it's too expensive. I'm going to go with, as soon as we have a few clear categories, it'll make sense to make a missense out of each category. And so I'm thrilled there's 3 patient-derived mice right now, but like Mike said, we didn't know that 2 were coming out. We didn't know 2 were coming out. We couldn't wait, so we funded this one. So with that, it's time to go to lunch.